Hello everyone, I'm Chiara Castellani, PhD student at Istituto Italiano di Tecnologia, and I'm going to present the solution that our team, the SIRSIIT, developed for the human-to-robot Handover track of the robotic grasping and manipulation competition held at ICRA2025. Our team is part of a joint research group between the Istituto Italiano di Tecnologia and the University of Siena, led by Professor Domenico Prattichizzo. The group focuses on robotics and intelligent systems, combining expertise from different academic levels and disciplines. The RGMC Handover Challenge is designed to promote the development of solutions for a fast transfer of objects from a human to a robot. Specifically, the Handover task consists of 3 steps. First, the human grasps and lifts the object. Then the robot approaches and grabs the item. And finally, it places it in its initial location. We also participated in the 9th RGMC at ICRA 2024, and this video shows an example of an handover performed during the competition. During the previous challenge, we mainly experienced 2 types of issues. The first was related to the detection module, which often failed under certain latent conditions, affecting the reliability of human hand recognition. The second issue was due to the employed gripper, which was not suitable for grasping large objects. In some cases, as you can see in the video, this resulted in an early object release. Our experimental setup comprises a Franca Amica Panda robot equipped with a customized version of the Franca hand gripper. Specifically, we employed a 90-degree wrist adapter to enhance the robot reachability, and we attached a soft fingertip extension to the gripper to enhance the grasp of larger objects and to increase safety during human-robot interaction. Besides, we employed 2 Intel RealSense cameras for the detection and tracking of the human hand and objects. The cameras were mounted on either side of the robot. 2 notebooks were used for processing data from cameras and for robot control. The perception pipeline we developed consists of 2 separate modules for the detection of the human hand pose and the object. To estimate and track the human hand pose, we process RGB data from the 2 cameras. From each RGB image, we extract the 2D key points of the hand using the MediaPipe library. Then, combining the depth information together with the 2D key points, we reconstruct the 3D pose of the hand. Eventually, we employ sensor fusion through Kalman filtering to combine the hand pose estimations from the 2 RGBD cameras. This approach allows us to enhance the robustness to occlusion and account for variability in human grasp types. In parallel, we perform real-time object pose estimation. Each camera's RGB image is independently processed, and distance segmentation is performed to identify and segment the object in the scene. The obtained object mask is used as a filter to extract the object information from the depth image. Eventually, the 2 point clouds are combined to create a unified and complete 3D reconstruction of the object. The information from the visual pipeline is exploited for the robot control. We continuously track the human hand pose and the object, and the robot motion is triggered as soon as the person grasps and lifts the object. We compute a suitable grasp pose based on the relative pose of the human hand with respect to the object, and we employ a PD controller to regulate the hand effector velocity, guiding the robot towards the estimated grasp location. As soon as the robot arrives in the proximity of the target, the gripper is closed. The robot then repositions the object on the table, placing it back in its estimated initial location. The RGMC challenge required a single user to perform 24 handover configurations, using 6 different drink and food containers with varying levels of fillings. The robot successfully completed 20 out of 24 trials, achieving a success rate of 83%. The average handover time was approximately 3.39 seconds, while the mean positioning error was 41 mm, demonstrating a fast and accurate solution. Thanks for your attention.